All right, so this is 30-2 lesson 5 out of this stuff. And this is where we're adding and subtracting rational expressions, part 2. The good news is that adding and subtracting rational expressions is the hard thing to do with them. Multiplying them, dividing them is not that bad. Solving equations is even really not that bad. It's just one little bit harder than the adding and subtracting. So adding and subtracting is really like the hardest stuff in the course, or in this section. I personally think it's the most complicated, if not hardest. But what we need to do is that we need to look at this thing as being a total factor. So in this case, I'm needing a common denominator between the binomials, but my common denominator will be this. Because I have one factor and another factor that have no common factors together, I just need to multiply those two pieces and then work those through. So if this is our work, I can see that this has this factor and this has this factor. The common factor is going to be both of them together. So what this is going to need is it's going to need me to multiply this original thing, top and bottom, by this factor. So there's my x plus 1, x plus 1, x minus 5, x minus 5. So here's my original, and then here's my new 1, my special 1 that I'm multiplying by to get that piece. So now what I need to do is I need to distribute this through. Again, in general, we don't want to distribute things through. We don't want to do it unless we have to. In this case, we have to because of this adding or subtracting. The adding and subtracting forces us to expand it so that we know what our common terms are. We don't want to expand our denominator because there's no reason to. We're not adding or subtracting to anything to it, and so it'd just be wasted effort. But now that I've got this, again, I'm going to take 2x squared and I'm going to subtract 1x squared. So that's going to give me x squared. Here I have 3x minus negative 9. Well, negative 9x is going to become positive x, so 3 plus 9x is going to be 12x. Again, if you're ever not sure, if you're not that confident with adding your integers, I mean, by all means, practice that, get better at it, get more confident. But if you're really not sure, type it into your calculator. People are always sheepish about that, but I would rather have somebody check their work with their calculator and get it right rather than feel like they shouldn't check their work and get a question wrong. 1 minus positive 20 is going to give me negative 19. And then this is going to be the x minus 5, x plus 1. Now at this stage, I'd have to see if this factors. It won't always factor, but it could. So I need to find two numbers that multiply to 19 and add to 12. Now 19's prime, so it's only divisible by 1 in itself. So there's nothing that's going to work for this. So it just stays as it is. This is my final answer because my numerator won't factor. And again, for 30-2, the only factoring we will be tested on, or should be tested on, at least on our diploma, what your teacher tests you on is between you and them. But the only things that we should be tested on the diploma are difference of squares factoring and common factor work. Okay, so here we go. In this case, I have a 2x and an x minus 4. I like to throw the brackets on it so I can see that those are factors. None of them factors, none of them can simplify. So here I have x minus 9 over 2x plus 3x over x minus 4. Now to get my common denominator, which is going to be 2x times x minus 4, this thing is going to need an x minus 4 in both places. So that's going to give me, I'm just going to distribute these two pieces as we go instead of writing them first down here and then distributing them and taking more work. So it's going to be x squared minus 9x minus 4x plus 36. So x squared minus 4x and minus 9x is going to give me negative 13x. Negative 4 minus negative 9 is positive 36. Over here, this is going to need a 2x and a 2x. So this is going to be just plus 6x squared. So my final answer here now is going to be 7x squared minus 13x plus 3 all over 2x, x minus 4. Now, I need to figure out two things that would multiply to 21 and add to 13. Again, there aren't any, so that just is as simplified as it can get. Same thing here, except with that tricky negative. Remember, be on the lookout for that. So this is a factor. I can't simplify that at all. There's nothing I can factor out. This is a factor. I can't simplify it at all. There's nothing I can factor out. So this thing is going to need a y minus 3 top and bottom. And this thing is going to need a 2y plus 5 top and bottom, not squared on top. Put that here, 2y plus 5. Okay, so now this is going to be 4 times y minus 3 minus 1 times 2y plus 5, all divided by y minus 3 times 2y plus 5. Now again, it doesn't actually matter what order I write those denominators in. I could do this one first, and then this one, or this one first, then this one. Multiplication is what we call associative and commutative, and those two properties mean that the order of multiplication doesn't matter. 3 times 4 is exactly the same as 4 times 3. So anyway, let's work with our numerator now. Our denominator's ready. Y minus 3, 2y plus 5. This is going to be 4y minus 12. Distribute that in, and again I have to carry this negative with me, minus 2y minus 5, right? And now I can put my like terms together, 4y and 2y make 2y, negative 12 and negative 5 make negative 17, all over y minus 3 and 2y plus 5. And I can't simplify anything further. Oh, look at me go. I've gone and forgotten my non-permissible values again, all the way across the board. In this case, my non-permissibles is x cannot equal 0 and x cannot equal 4. In this case, my non-permissibles is y cannot equal 3, that's from here. And in this one, again, sometimes is a little trickier to see, but it's y cannot equal negative 5 halves. And again, if you're having trouble seeing that, break it out as a separate thing. Just go 2y plus 5, that's my denominator, can't equal 0, and then isolate for y. So 2x can't equal negative 5, therefore y. I'm changing my variables as I go. Look at me go. You're probably screaming at the screen going, McManus, stop! And that's all good. Please do that. But there's where that piece goes. When we have denominators with common factors, my first step is always to factor. Remember we did that when we had something like 6 times 4, I said, or something like that. I said, well, that 6 is really 2 times 3, and the 4 is really 2 times 2. And I can see that they have that common factor. Here we're going to do the same thing. But what I do is I'm going to take this, this 4p squared minus 1. They've already done this here. I'm going to factor that, and that factors to p minus 1, p plus 1. That's that difference of squares that should just be, drilled into your brain such that when you close your eyes, it haunts you. It's imprinted on the back of your eyelids. A squared minus b squared equals a minus b, a plus b. If you are stricken by Alzheimer's later in life and you're in your mid-80s and late 80s and having trouble remembering your spouse's face, I don't wish that upon anybody. But if you get there, you should still remember your difference of squares. That's how strongly we want this thing imprinted in your brain. Maybe not quite more than your spouse, but on the same sort of playing ground maybe. Anyway, so this is that difference of squares, p minus 1, p plus 1, and then we would multiply, in this case, both things by the missing piece. It already has a p plus 1, so all it needs is the p minus 1. And again, they did that work for me here. So now all I need to do is just continue on. So I have to expand this. So this is going to be 4 over my common denominator now. And what I'm going to have here is I have to distribute this thing through, and it's a plus 2. Got to be careful, always look on the lookout for minuses. So 2p minus 2, and now I put together my like terms. So 2p minus 2 all over p minus 1, p plus 1. Almost done. That's awesome. And we actually did write down our non-permissible up here, which is good. I keep forgetting to do that early. And again, hopefully you're screaming at the screen, non-permissible values! And that'll all hear you. Why am I changing p's and y's here? Let me change that. Put that back to a p. Look at me go. Okay, all right. Back to where we need to be here. And now what I see is that I can always factor. Again, I always want to check my factoring at the end. So I could have maybe thought I was done, but now when I simplify this, I could take out a 2. That leaves me with p minus 1 over p minus 1, p plus 1, and hey, what do you know? They have factors in common. Remember, you can't slash out common factors, and we only get rid of common factors, not terms, only factors. But I can't slash out those common factors unless I have already attributed its non-permissible value. That's like your gatekeeper. You can't do it unless your non-permissible value piece is done. All right, so over here, we're going to work through a couple more of these, and then we're going to move on to the next topic. So first thing I want to do is always factor. So step 1, factor. Step 2, NPVs. Okay, so first off, I can take out a common factor of a 5 out of here. This is x plus 1. I can take out a common factor of a 2 down here. That's x plus 1. And hey, now I see that I actually have a common factor. I might not have seen that initially, but x plus 1 is actually common. So what do I need to make my new common denominator, which is going to be 2 times 5 times x plus 1? This half of the fraction is going to need a 2, 2, 2. That's going to get me to the 2, all those 3 pieces, right? 1, 2, 3. That'll get me there. So this is going to be 8 over my common denominator. On this side, it has the 2. It has the x plus 1, just missing the 5. So I include a 5, again, numerator and denominator. So 8 plus, that's going to now be 15. 3 times 5 is 15. 8 plus 15 is 22 over 2 times 5 times x plus 1. And now, we can actually reduce this a little bit because this has a factor of 2 as well. So 2 times 11, 2 times 5 times x plus 1. And look at me go. I even wrote down step 2 is NPVs, and I just get so, caught up in the whole thing that I forget my NPVs. I can always get to them at the end, as long as I make sure I've included my NPVs before I cancel anything. But I'm about to cancel this 2. 2 doesn't have any NPVs, but this x plus 1 does. So x cannot equal -1 is the restriction on my variable. -1 is my NPV, but I could write my restriction as x cannot equal -1. All right. Again, step 1, factor. I'm going to remember my NPVs this time. I am. Right away. First step factor, second step NPVs. So this still stays 1 over x. This is going to be 1 over x plus 2. Now, I remembered it was only 30 seconds ago, but NPVs, my NPV here is x cannot equal 0. So 0 is my NPV. My restriction is x cannot equal 0. And then here it's x minus 2, right? Or x cannot equal -2, because -2 plus 2 would make 0, and that puts a -2 or a 0 in my denominator, which is undefined, right? It just doesn't make mathematical sense. It goes against the actual idea of division, which is really grouping. That's all division really is. So now what I need to do is get my common denominator. So let's write these steps down here. Common denominator. Okay, so my common denominator, it already has the x in both cases. This side needs an x plus 2, and then in my numerator also an x plus 2. So now what I have is my common denominator, x plus 2. And I now have in my numerator, distributing that through, that's just going to be x plus 2 minus 1. So I now have x plus 1 over x plus 2. And I am good to go. And did I write my NPVs? I did. Look, I can be taught. So common denominator. And then again, once we put our common denominators, then we just like terms and simplify the numerator. And then step 5 is check for factoring. Check to see if the whole thing simplifies. Which in this case it doesn't. It did in this case, it doesn't here because x plus 1, x and x plus 2 will have no common factors anywhere. Okay, so here's where a student did some work. We need to just complete the student's work. So step 1 was factor. Step 1, factor. Did they do that? Yeah, they did. Awesome. Now, what they did here is they said, wait a sec, here this looks like x minus 3 and 3 minus x. Those are actually the same factor. What I'm going to do is take out a negative 1 first. 3 divided by negative 1 is negative 3. Negative x divided by negative 1 is positive x. And then instead of negative 3 plus x, I could write that as x minus 3. Now I can see that they have that common factor together. The missing factors, well, this thing needs a negative 4 and a negative 4. And this thing here needs a 3 and a 3. But you need to be careful of those factors that don't look the same but are actually common. As long as we just take out negatives to always make our x term first in the bracket, that should make our life easier. So this is going to be 3 times 4 is negative 12. Well, actually, I don't even need to do that. I'm just going to do this in my denominator for now, and I'll put it together after. But factored is fine in my denominator. It's only in my numerator that I am forced to expand by this addition or subtraction. So that's 3x plus 15. And then what I have here is negative 8x plus 3x is going to be negative 5x plus 15. So here I have negative 3 times 4 times x minus 3. And now I can actually take out a negative 5 from my numerator. And that will leave me with, oh, x minus 3. Look at that. It's going to simplify. Now, did they write down their NPVs up here? They didn't. I should have when I factored, but I was letting them do the work. So let's go back up to here. X cannot equal positive 3. Again, this is actually the same limitation in either case there. It's both x cannot equal positive 3 because it's actually the same factor, just disguised with a negative 1. But now that I've written that out, now I can cancel my like factors, right? I'm not really just canceling. I'm kind of dividing it. You can think about this as x minus 3 over x minus 3. And anything which has the same numerator and denominator, this whole piece is 1. So that just simplified to 1. Anything divided by itself is 1. So we have negative 5 over negative 3 times 4, which is the negative and the negative are going to cancel each other out and become a positive 1. So it's going to be 5/12. Wow. Cool. All right. Hopefully that makes sense. If you have any questions, as always, come ask and enjoy.